So in this lecture, we will be deriving the equations of motion using graphical method. So starting from first equation of motion. So we have a very special case. Here we have this graph. This is a velocity time graph. And if you look at this graph, we can see that from time starts at 0. So at time is equal to 0, the object is moving with initial velocity u. So u is the initial velocity of the object at time 0. We can say that initially at time 0, the object is moving with velocity u. So u is initial velocity of the object. All right. And as the time goes on, as the time passes by, the object velocity increases constantly and linearly. The velocity is increasing. And as time reaches to t, the velocity of the object is v. Here the velocity is v. So we can say that as the time goes on, like this, the velocity increases from initial velocity u to final velocity v. This is our final velocity at this point. All right. So now we know that the gradient of velocity time graph gives us acceleration a. This is known. We have studied in previous lectures that the slope of velocity time graph is equal to acceleration. So the slope of this graph, see, the slope of this graph gives us the acceleration. So writing the mathematical formula for slope, gradient is equal to change in velocity divided by time. All right, this is by the definition of gradient, or this is by the definition of slope. The change in velocity divided by time gives us gradient, or it also gives us acceleration a. Okay, so what is the change in velocity here? In our case, the change in velocity is final velocity v, this is v, minus initial velocity u. Okay, so change in velocity is v minus u divided by time, and this is equal to acceleration. Now we can multiply both sides by t. So if we multiply this side by t and we multiply this side by t, so we can get v minus u is equal to at. Okay, and further moving the u to other side, we move u to this side. Okay, so what we get finally, v equals to u plus acceleration into t. So this is our first equation of motion. Final velocity is equal to initial velocity plus at. V is the final velocity, u is initial velocity, a is acceleration, and t is time. So this is our first equation of motion. Final velocity is equal to initial velocity plus acceleration times t. Okay, now we will derive second equation of motion. Okay, so second equation of motion basically tells us about the displacement s. Okay, so we have again a velocity time graph that we studied in previous slide or previous equation. This is again a velocity time graph. The same case is discussed here. The object is initially at time 0 moving with velocity u, which is the initial velocity, and at final time t, the object is moving with velocity v, which is the final velocity. All right, so from the definition in our previous lectures, we have studied that the area under a velocity time graph, this area that we have shaded, this highlighted area, this will be equal to the displacement of the object. So from definition we know that the area under a velocity time graph is equal to the displacement. Alright, the area under a velocity time graph is equal to displacement of the object. So if we can somehow calculate the shaded area, this shaded area, if we can somehow calculate this area, we will find the displacement as well. Alright students, so now what we will do, we will find this shaded area, and the simplest way to calculate the shaded area is to split up this graph into smaller shapes. Okay, so we have split this graph into two shapes. This one is a triangle. See, this is a triangle, and the portion below this is a rectangle. Okay, this is area 1, this is area 2. The sum of areas 1 and 2 will be equal to displacement. So now what do we have to do? We have to find area 1 and we have to find area 2. Then we will add both of these areas. Okay, we will add 1 and 2 and we will get the overall area under this velocity time graph, and that area will be equal to the displacement S by definition. Okay students, so now see here, let's calculate the areas individually, area 1 and area 2. So area 1, this is area 1, this is equal to u multiplied by t, because this is a rectangle, and by definition we know that area of rectangle is equal to length multiplied by, this is length multiplied by breadth. So this is length t and this is breadth 0 to u. So u multiplied by t, this is area 1, area of a rectangle. Okay, now we will calculate area 2. So area 2, it is basically a triangle. See, this is a triangle, and we know that area of a triangle by formula is equal to 1/2 base multiplied by height. So we have, this is the base, this is our base, the horizontal line, this is our base. Okay, and this is our height. So we can see that base is equal to time t. See, this is the base and this is equals to t, and the height, this is height, the height is equal to v minus u. See, so simplifying this equation, area is equal to half cross t multiplied by height, which is v minus u. Moving forward, earlier we saw that v minus u was equal to 80. Alright, we saw it previously that v minus u was equal to 80 from first equation of motion. So we put it in our equation here, half t, and we have replaced v minus u by 80. So we get half multiplied by t multiplied by 80. So finally the area is equal to half a t multiplied by t gives us t square. Okay students, now the total displacement will be equal to the sum of area 1 and area 2. We have found both area 1 and area 2. So the total displacement is the sum of areas 1 and 2. Okay, now we will just put the values of area 1 and area 2 in this equation. So we get area 1 is ut and area 2 is half at square. So we get displacement is equal to ut plus half at square, and this is our final second equation of motion. Alright students, now we will find third equation of motion. Okay, this is a bit complex method because it involves a lot of mathematical operations and mathematical calculations. So We will use both of the equations, equation 1 and equation 2, that we have already obtained so far, to reach and to find the third equation of motion. Now we have noticed that both our equations, the second equation, that was S is equal to ut plus half at square, and the first equation, that was v is equal to u plus at, it includes the time variable t. Both of them have t and t. Okay, so there will be some situations when we do not have information about time. So it would be a good idea to derive an equation that does not have a time t term. Okay, so to do this, we rearrange our first equation to get t is equal to v minus u divided by a. Where did this come from? It came from our first equation here. Okay, from here we have got the value of t. So t is equal to v minus u divided by a from this particular equation, all right. So we will use this to replace t wherever it appears in the second equation. So we will put this value of t in our equation number 2. This is our equation number 2. Okay, moving forward, this is our second equation of motion, and we will put the value of t here. This is the value of t. Okay, so replacing t by v minus u divided by a, we get s is equal to u, and we have replaced t by this ut plus half a t square. So again half a t is replaced by v minus u divided by a. Okay, now we will just simplify this equation. So we will start by taking a out of the squared bracket. Here we have a, so we will take it out. Simplifying, we get s is equal to u v minus u divided by a plus half into a v minus u square divided by a square. We have just separated out a. Okay, simplifying again, we have s is equal to u v minus u divided by a comes in its place again, plus half a square and a, so this gets cancelled by the square. Okay, so the remaining thing, we have half v minus u square divided by a. Now a and 2a we get common. Moving forward, we remove fractions by multiplying both sides of equation by 2a. Here we multiply 2a to this equation. So when 2a is multiplied on this side and on this side as well, so we get 2as is equal to 2u into v minus u, a gets cancelled, plus u minus v square. The 2a is multiplied, so it gets cancelled here. Okay, so we have final this equation, and we will simplify it further. So 2as is equal to 2u is multiplied with this thing in bracket, so 2uv minus 2u gets multiplied to u gives us 2u square plus v minus u square. So we use the formula a minus b whole square is equal to a square minus 2ab plus b square. See, v minus u square is simplified and we get this. So now the next step, 2as is equal to 2uv gets cancelled with minus 2uv, and minus 2u square plus u square gives us minus u square, and v square comes on its place. So 2as is equal to v square minus u square. V is the final velocity and u is initial velocity. We can also pronounce this as 2as is equal to vf square minus vi square. Vf is final velocity and vi is initial velocity. So this is our final equation, which is third equation of motion. V square is equal to u square plus 2as. V is the final velocity, u is initial velocity, a is acceleration, and s is displacement. So we can say final velocity square is equal to initial velocity square plus 2 times acceleration multiplied by displacement. Okay, thank you. And we have derived all the 3 equations of motion in this lecture. Furthermore, subscribe to my channel to get more videos on acceleration, velocity time graphs, position time graphs, mechanics, and further physics videos. Thank you so much.